Hello friends, in the previous video we have seen that a design and simulation of single phase inverter in the open loop control, and in this video we are going to see that closed loop control for the same inverter. So here in the PWM generation block we have used internal sine wave generation, that is it's going to generate internal reference signal sine wave. Now we are going to disable that, and the sine wave is going to feed from that PID controller. So we need to use a sine wave block, and it will be configured with a constant 50 Hz frequency 2 into pi f, and amplitude will be 1. Then we need to use a PI controller. Then we have to multiply both. So what is going to happen here, this sine wave block is going to generate a sine wave with a constant amplitude and constant frequency. This PI controller is going to multiply with the sine wave to adjust that amplitude. So here by default I'm giving 0.1, 0.1, and then upper limit is 1, lower limit is 0, initial value will be 0. Actually the purpose of using PI controller is to maintain that output value at the constant reference value. So in the stable the control system, anything is okay. Inverter or converter or motor control, anything is okay. In the stable system we can control that output parameters as a constant value. So here we need to give a error value. So I'm going to subtract the feedback value from the constant reference value. So I need a 230 volt output voltage is constant. Then here VRMS should be global. Then I'm going to read this here in the subsystem. So this will be V out. So the output voltage, that is feedback voltage, is subtracted from the reference value, and it will give that error, and error is going to that input of PI controller. The PI controller will be that output of PI controller will be reference signal or control signal. This will be multiplied with a sine wave, and the multiplied output, that is reference signal, it's going to compare with the internal triangle value. So now we'll simulate and check. So I'm going to debug here. I'm adding mux. So scope, let's simulate. In this simulation we can also see that input voltage changes, and output load changes. So which means load variation, how the inverter is reacting based on that load variation, and how the inverter output is reacting based on that input voltage changes. So whatever it is changes, when we are increasing the load or decreasing the load, the output voltage should not change. It should be maintained as a constant value. And when we are changing the input voltage, so the output voltage should be constant at the reference value. So we can see here, our yellow color is our reference value, that is 230 volt, and blue color is a feedback signal from the output, and the second signal is output of PI controller. So we have a integrator inside the PI controller. It's going to start from that 0 and it will start integrating. So the output voltage will start increasing. So when that voltage reaches the reference value, so it's going beyond the reference value, so it will start decreasing. So it's the purpose of integrator. So when we are giving the positive error signal, it will integrate, so it will increase. So when we are getting error in the minus value, it will start decreasing, right? So this is happening here. So when the output voltage reaches the reference value, it will be constant, right? Now we'll check that load variation. So I'm going to add a breaker. So it's going to turn on and turn off at 0.25 second. Initially it will be open, so which means I'm increasing the load. So earlier it was 1 kilowatt. So till 0.25 second it will be 1 kilowatt, and after 0.25 second it's going to turn on, and another 1 kilowatt will be added. So the total power will be 2 kilowatt. So now you can see here. So the after 0.25 second we added one more 1 kilowatt load. So the voltage starts decreasing, and again the PI controller starts increasing. The output of PI controller will increase to maintain that output voltage is constant. So it's working fine. So now we'll see that input load line variation. We'll see what is the input voltage. It's a 400. So I'm going to add controlled DC voltage source. Controlled voltage source. So it should be DC. Initial voltage will be 0. I'm going to add a step block. Now we'll see voltage dip. So step time will be 0.25. Initial value will be 400. Final value will be 300 or 350. So now we can see here after 0.25 second the input voltage reduces, so which means the inverter can't maintain that 230 volt as the output when the input voltage reduces. So what is happening is the PI controller starts increasing to maintain that output voltage is constant at 230 voltage. Now we'll see voltage rise. I'm giving 450 volt. Yeah, so now for the voltage rise, we can see here after 0.25 second the input voltage will be increased to 450 volt. So for this duty cycle, so what is the modulation index? Not a duty cycle, modulation index. So earlier for 400 voltage input, the modulation index is in between 0.75 to 76. So for this modulation index and for the input voltage of 450 volt, the output voltage will be more. So the output voltage starts increasing. So that PI controller is decreasing to maintain that output voltage at 230 voltage constant. Right, so the purpose of PI controller, it is used to maintain that output voltage feedback at a constant level or at a reference level. So when we are giving 230 volt reference, it should maintain at 230 volt output voltage by adjusting the modulation index automatically. So in the open loop control, we are going to adjust modulation index based on that output desired voltage level. So here it will adjust automatically based on that input voltage variation and output load variation. So we can also see how to tune that PI controller. So now I'll give a constant input voltage. Now we'll observe the settling time and transient everything. So here the settling time is around 0.1 second for this 0.1 and 0.1 kp, 0.1 ki. So now I'm adjusting kp. See, now that the settling time is increasing, so that proportional gain will be helpful to decrease that or adjust settling time and steady state error. So the integral gain will be helpful to reduce the oscillations or increase the oscillations. So when we are observing oscillations at here, so when we are observing oscillations at this feedback voltage, so we need to adjust that integral gain. So when we are observing steady state error, so which means our reference value is 230 volt, it is settling at 220 volt or 225 volt or more than 230 volt, which means 232 or 235. That is a steady state error. To adjust that steady state error, we have to adjust that proportional gain. And so when we are increasing that kp value, we can see that the settling time will reduce. So now for the 0.01 kp, the settling time is around 0.35. So when I'm giving 0.1 as kp, so it was settled at 0.1 second. So this is the way of tuning the PI controller. Okay, so we'll see in the next video. Thanks for watching.